Hello, we're going to review the Shunting Yard algorithm today. I'm going to be using the canvas in JGrasp. And so what we see here is going to be our input. This is going to be a queue that has an infix expression, and it's represented by a linked list. These are the linked list nodes, and so you can see how they're linking to each other. And then this is the content in each of those nodes. Here is going to be our operator stack. So we're going to put operators onto this stack. Over here is just a temporary thing for our token. And down here we have our output queue, which right now has nothing in it. So we're going to step through this infix expression and we're going to see what happens. So when I see the 5, I'm going to put that into my temporary token here. And so you see that I dequeued it off of my input and it has landed into my temporary. Now I have to decide what I'm going to do with it. Do I want to put it in my operator stack or do I want to enqueue it onto my queue? Well, it's not an operator, so it should be obvious that I'm going to enqueue it onto my output. So the 5 has come here. We're going to go back up and look at the plus sign, and the plus sign is now over into my temporary token. You can see that my token now understands it's an operator, and we're going to see if we can, what to do with that. We're going to look to see if we can push that onto the stack, and we certainly can, so we will. So you'll see that this operator gets pushed onto the stack. We're going to look at the 7. The 7 is a number, it's not an operator, so that's going to go into our output queue. Now, at the head of our queue for the input is another plus sign. So we put that into our temporary token. We're examining this. We have to decide whether that can go onto our operator stack. One of the conditions that it goes onto the operator stack is that the precedence of this token is greater than the precedence of this token. Well, those are the same operators, so the precedents are equal, and so it cannot be pushed onto the operator stack. So instead, we need to pop off the stack until we have the ability to push it. When we pop off this stack, we're going to put it onto the result queue. Now that we have our stack is empty, we know that we can push it onto our stack, and then we're going to go look at the 2. The 2 goes in a temporary, it's a number that goes into our output token or output queue. Now once again we have plus that we're examining. We took that off of our input, and plus once again is equal or has the same precedence as the plus sign. So we're going to pop the plus, put that into our result queue, and then we're going to push the plus sign in there. I know it looks a little odd, but if we had pluses and minuses, which we're going to see here in a second, it makes a difference in how it's operated. So now we're going to look at the 1. The 1 is a number. It goes into our result. Now we're going to look at the minus sign. The minus sign has the same operator precedence as the plus, so we're going to pop off the plus from the stack and push it into our results queue. Once we've done that, we're going to push our minus sign onto the stack and then go back to examining our input. Our input is 3. That is a number that goes into our output. Our next token is a plus sign. The plus sign is the same operator precedence as the minus, so we're going to pop off the minus, and then we're going to push the plus into the stack. Now we go back up to our input. Our input is the number 2. That goes back into our result. And now our input is empty, so we take whatever we have in our operator stack, pop all the remaining tokens out of there, and just enqueue them into a result. So what we see at the bottom here is the postfix expression of what we had at the start. Let's go test out another one. This one is a lot more complicated. It's a little bit longer, and it has parentheses and multiple operations. Finally, something of interest. We're going to look at that open parenthesis. And the open parenthesis, we always can push onto our operator stack. So that goes there. We're going to look at the 1. 1's a number that always goes into our result stack. The plus sign is going to be examined. We can push that onto the operator stack if the stack is empty or if the operator is greater than the precedence of the stack, or if if the stack has an open parenthesis. It has an open parenthesis, so we can push that onto our operator stack. We're going to examine the 2. The 2 doesn't say anything. The 2 goes into the results. Now we examine the closed parenthesis. When we see a closed parenthesis, we're going to pop all the operators off of our stack until we get to the first open parenthesis, and then we'll discard the parentheses. So we're going to pop off the plus, and we're going to put the plus on the results, and then we're going to discard the open parenthesis, and then we're going to discard the closed parenthesis, and then we're going to go back to the input. The input has a multiplication. Our stack is empty. That can fit just fine onto our stack. We look at the number 3. The number 3 always goes to our result stack. Now we're going to look at the division sign. The division sign and the multiplication sign have the same operator precedence, so we can't push it. Instead, we need to pop off the stack until we're allowed to push it. So we're going to pop off the multiplication. Now that our stack is empty, we can always push on an empty stack. And then we're going to go back up to our input. Our input has the open parenthesis. Open parenthesis always gets pushed. We look at the 1. The numbers always go to the results queue. You look at the multiplication sign. The multiplication sign can always go on top of an open paren. It's the same as if it was empty. We have another open parenthesis. The open parenthesis can always go onto the stack. We have our 4. Numbers always go to the result queue. We have our division sign. Well, as we examine that, we see that our stack has an open paren, so we're going to push that onto the stack. The number 2 says that we always push that, NQ that into our results queue. Now we have a closed parenthesis, so we're going to go into our now we have closed parenthesis. So we're going to pop off of our stack until we have the matching open paren. We'll discard both the parentheses, and we'll put all the operators between those into the result. Here we have a division sign that's going to go into the output queue. And now that our stack has finally hit the open paren, we discard that. We look at our infix. That is a closed paren again. So now we're going to pop off until we hit the matching open paren. In this case, it's multiplication. That'll get popped off into our results. And then we have finally the open matching paren. We'll discard that. Now our input is empty, yet our stack is not. So now we just pop everything out of the stack and put that into our result queue. So down here, now we have the resulting postfix expression that matched our original infix expression. This one has a few more parentheses. We'll go a little bit more quickly. We're going to examine the open paren, and that's going to go onto the stack. Examine the open paren, that goes onto the stack. We're going to look at the 1. The 1 goes into our result queue. The plus sign, it's an operator. We can always put that on top of the open paren. Now we look at the 2. The 2 is going to go into our result queue. The closed paren will match until we get the open paren. So we're going to pop off the plus sign, and then we're going to discard both parentheses. We're going to look at our input queue. We have the multiplication. That can be pushed. So we'll push that onto the open paren. And then we'll look at our 3. The 3 can go into our output queue. We're going to look at the plus sign. The plus sign has a precedence that is lower than the multiplication. Therefore, we need to pop off our stack because we cannot push the plus sign onto our stack. So we're going to pop off that multiplication until we can. We're going to keep popping off the stack until we are allowed to push the plus sign. The plus sign can go on top of an open paren, so that's where it will go. We look at the input. The input is 1. The 1 is going to go to our output. Now we have our matching closed paren. So the matching closed paren is going to make it so we pop everything out of the stack until we get the matching open paren, and then we'll discard the parentheses. We'll go back to our input. Our input is the multiplication. that's going to go onto our stack. And then we look at the 2, which is a number that goes to our output. Now we say, A, our input is 0, it is empty, so now we just pop everything off of the stack and queue it to the end of our queue. So now we finally have our expression that matches our postfix expression that matches our original infix expression. We got all these parentheses. Well, the open paren is going to go into the stack. The open paren is going to go into the stack. The open paren is going to go into the stack. The open paren is going to go into the stack. The 1 is going to go into the output queue. Now we got a plus sign. That's going to go into our stack. The 2 is going to go into our output queue. The closed parenthesis is going to cause us to pop off the plus and discard the parenthesis. Multiplication is going to go into our stack. We got our 3 is going to go into our output. The minus sign does not have greater precedence, so we need to pop off the stack. So we're going to pop off the multiplication, then we're going to push the minus. The 1 is going to go into our output. Now we have a bunch of closed parentheses. So we're going to pop off all the operators telling me it's matching parentheses. In this case, first one's we're going to pop off that minus sign, and then we're just going to keep discarding parentheses as we go through. So now we're going to have the multiplication we're going to look at. That can go onto our stack. Then we're going to look at our 2. And the 2 is going to go in our output. Our input is all empty, so we pop off the stack. So this is our postfix expression that matched our infix expression. All right, that was enough examples. You should watch this again with the volume off to see if you can predict what will happen.